other girls are playing with dolls. We image like we are in laboratory. We obtain some special strain, Anabena variabilis, that are produce the hydrogen in high amount that can compete with the other results that are obtained before in foreign countries. We can use this strain for obtaining of hydrogen in the large-scale productions. I feel myself so fulfillment and in my place.
The modern world is impossible to imagine without transportation. It brings people, cities and countries together, making life easier and more accessible. However, the rapid development of transportation has created serious environmental challenges. Cars, trains, ships and airplanes powered by fossil fuels release carbon dioxide and toxic fumes into the atmosphere. This pollution harms human health, damages ecosystems and poisons the air we breathe. Large cities suffer the most, where thick smog has become a part of everyday reality. Electric transport marks a significant step forward in the fight against air pollution. Powered by electricity, it produces no toxic emissions. Another promising solution, according to experts, lies in the use of biofuel, a clean energy source derived from vegetable oils, food waste, water, and agricultural byproducts. Biodiesel is suitable for a wide range of transportation, including cars, trucks, trains, and ships. Kazakhstani scientist Ardak Kakimova has made a groundbreaking discovery in the field of sustainable fuel production. She identified a strain of bacteria capable of producing eco-friendly fuel in much larger quantities than traditional methods allow. This research holds the potential to make clean energy widely available while significantly reducing its impact on the environment.
It's the project that aims to obtain the hydrogen from cyanobacteria. The cyanobacteria is photosynthetic bacteria. It's autotrophic microorganisms that can lead the photosynthetic process, photosynthesis in their cell. Yeah, so they can use just light, water, and split it to hydrogen. So mainly these microorganisms are present everywhere. Ways mainly in, of course, water ecosystems. In our laboratory, we start to use this microorganism to obtain hydrogen because the hydrogen is like alternative source of energy. First thing what we do, visit some places. For example, it can be hot springs or some salt lakes, or it can be some salt soils, yeah. And we take some samples, and in laboratory conditions, we isolate the pure culture. And the next step now, first what I should do, yeah, to prepare the smear, first I should sterilize this. When we prepare the smear from solid media, it needs some physiological solutions, some solvents, but in case when we prepare from liquid media, it is more easier. We just need our liquid media, the dosator, and we just take it and open, sterilize, and take some piece of sample, put it inside the plate, again sterilize, and we will just close our sample covering.
The obtained smear is then examined under a microscope to identify the microorganisms present. Using antibiotics, antifungal agents, or ultraviolet radiation, researchers isolate cyanobacteria from other microorganisms. Once the cyanobacteria are fully purified, scientists begin experiments to determine the best conditions for hydrogen production.
The main important results that we obtain some special strain, Anabena variabilis, that are produce the hydrogen in high amount that can compete with the other results that are obtained before in foreign countries. This Anabena variabilis is filamentous cyanobacteria that are contained from vegetative cells, and from heterocystic cells. So these heterocystic cells is mainly work like a spore, but it's not spore. Yeah, this is also like a living cell, but this heterocystic cells is very important in obtaining of hydrogen. Why? Because this cell wall is very thick, and this thick cell wall is protect the cell from oxygen. So it's like naturally create some anaerobic conditions for this bacteria, and because of this, inside of these heterocystic cells, enzymes can be active every time. And we isolate this Anabena variabilis strain from rice paddies of Kazakh region, and during the working with this species, we indicate that this Anabena variabilis can be very potential producers of hydrogen. When we compare the obtaining results, it was very high comparing with other cultures that we have in our laboratory. For utility model of Anabena variabilis, we obtain patent of Kazakhstan, and in future, for example, we can use this strain for obtaining of hydrogen in the large-scale productions.
The laboratory in Almaty was the first in Kazakhstan to develop technology for producing hydrogen using cyanobacteria. The field of hydrogen energy opens up entirely new opportunities for the country. Similar research is already being actively pursued abroad. Kazakhstani scientists have established strong partnerships with leading international research centers, exchanging valuable experience and sharing their own achievements. The discovery of the Anabena variabilis strain caught the attention of a professor from Tennessee State University in the United States, who has been working in this area for nearly 50 years. He recently proposed continuing joint research on this topic.
Tokyo Science University and the Ardak Center in Czech Republic bring international prospects to this research. Research is incredibly relevant because of the two global challenges. First one is need a new alternative energy sources, and the second one is the mitigation environmental damage caused by fossil fuels. So this project by hydrogen production is important in the case of the using environmentally friendly organisms, cyanobacteria. As you know, cyanobacteria is the unique microorganism which is capable to photosynthesis process. We know photosynthesis is the essential for the carbon emissions and the carbon fixation from the environment and the releasing of the oxygen to the environment. It's innovative approach to combining in fundamental microbiological research and the practical applications in bioenergy production.
When I'm thinking about the future of my project, the first thing that is mainly I concern, it's now it is impossible to make some large-scale production of this hydrogen, and here like several problems that are lead to this problem. Yeah. So first problem is related to the absence of relationship between different directions. Like not only biotechnologists should work on this direction, like biotechnologists, physicists, chemists, yes, like from different directions, and together like it will be more easy to solve all these problems, because like hydrogen is gas and cyanobacteria that produce it, and we should have some equipment that can help us to collect this gas and save in some special spaces. And the second one, the problems that appear when we want to cultivate the cyanobacteria, for example, in big photobioreactors, because in open photobioreactors, because during the cultivation of these microorganisms in open bioreactors, it can be contaminated very fastly. Yeah, so some methods that can help us to keep them clean even in the open or closed tubular photobioreactors. It is very important to create these methods. From the young years, I remember how I like to work as a scientist. I have a friend, and we always work together. For example, in playground, when the other girls are playing with dolls, we like to play like in laboratory. We image like we are in laboratory and prepare different kind of smears from the soils or from the plant leaves or from the grasses, yeah, and we image like a detective. We want to find something, discover something, and it was very, very interesting. And nowadays I am a biotechnologist, and my friend she's in field of medical biology actually. And I remember like in my 8th class, I have watching the TV program, and in this TV program was Sultanat Baykoshkarova. Sultanat Baykoshkarova is the first people who is developed the extracorporeal fertilizing in the Kazakhstan. Yeah. So and I remember it's very, very clearly that after when I watched this TV program, she told that she graduated from medical biology department, and that time I have decided inside myself that after ending my secondary school, I will go for a bachelor degree. I have realized that biology and the science can solve real world problems, and I also want to be part of this science.
For Ardak Kakimova, biology is not just a profession, it is her life's calling. She completed a master's in biological sciences and later defended a PhD in biotechnology. Today, Ardak successfully balances the roles of scientist, wife, and mother. With the unwavering support of her family, she can focus on research and participate in international conferences. One of her favorite ways to unwind is walking, which helps her recharge and find inspiration for new discoveries. Dr. Kakimova believes that science, family, and personal interests can harmoniously complement each other when there is dedication to your work and support from those around you.
I didn't have even small thoughts about living science, I feel myself so fulfillment and in my place. During the working in laboratory or making different kind of experiments, first thing that I understand and realize it is about persistence and adaptability. These two features are very, very important for scientists, I think. Why persistent? Because sometimes we didn't get the good results, and some fails, we can meet some fails, but these failures shouldn't stop us, and we should repeat and go on. And the second one is adaptability. Why adaptability? Well, because adaptability to different conditions or to different changes that can happen in a science field, like the changing of protocols, the changing the full experiments. So everything is can be changed very fast. So that time you should be very adaptable, And every time when we, for example, have some scientific trips or some internships in other countries, it is also very important to be adaptable and to find some to create some good relationships with other laboratory members.
By the age of 32, Dr. Kakimova has published over 10 articles in highly cited scientific journals. She believes science holds the key to understanding nature and solving the world's most pressing challenges. Ardak sees great potential for the growth of science in Kazakhstan. She is confident that investing in this field will not only strengthen the country's global standing, but also make science a meaningful part of everyday life.
Cyanobacteria are one of the oldest organisms that appeared on the Earth, and that's how they created really good abilities. For example, they can survive in the temperature under 65 degrees Celsius and under high pressure, so they have a great potential in different aspects of biotechnology, medicine, and also in bioenergy.
The topic of your research have many advantages under the other methods. At first, it's renewable method, so we can use, for example, the wastewater to produce biohydrogen. Also, it's very eco-friendly, so there are no contamination of the environment by, for example, chemical compounds, like in the case, for example, in production of fuel, of traditional fuel.
In addition to her scientific work, Ardak teaches biotechnology and microbiology at the university. She also leads students' environmental projects focused on protecting the natural beauty of Almaty.
From the early autumn to the late spring, we like to go to mountains, and first, of course, we arrange some picnic, and we have some special time for us, and after that, during the in back side, when we return home, we collect all the plastic bottles or rubbishes, and we deliver these plastic bottles to special place where they recycle these bottles. These kind of events mainly help to students be involved in ecological and social activities.
A future where biofuel becomes a viable alternative to gasoline and fossil fuels is a world with a clean environment, free from harmful emissions. In this world, energy comes from renewable sources and technology works in harmony with nature. It is a future where environmental pollution is significantly reduced and natural resources are preserved for future generations. Ardak Kakimova is the face of Kazakhstani science. Her research in hydrogen generation for biofuel paves the way for clean and sustainable solutions.